Hello, 7th graders. Let's start our Chapter 4 review on data analysis. In this chapter, we started with doing a survey of a population. The population might have been middle schoolers at St. Joe's. The population might have been our whole school, but the population would talk about the whole group. Then we picked some people in the group to do our survey too, and that group was as random as we could possibly make it. And so when we pick a random group, that is taking the bias away from a survey. A bias is kind of like, think of it as making it unfair, where like one of your choices might win more likely because of who you picked to ask. So you don't want to pick your best friends. You don't want to pick only the kids that are on the soccer team. You could do it randomly. You could put everybody's name in a hat and randomly draw them out. This would work for a smaller group, but if you had a group that was over 100, you wouldn't want to do that option. You could do a systematic sample that's choosing every so many people. So like if you stood at the door to somewhere and picked every fifth person to ask them a question, or a stratified sample would be where you're picking randomly and then picking randomly within that random group. So maybe you pick put everybody's class in a hat and you draw one class out and then you say, okay, every fifth person in the alphabet from that class, I'm going to ask them a question. So you did two different things. Okay, so if you survey every other person that walks into Walmart and ask them if they prefer Walmart or Target, is that biased? Yes, it is, because they're going into Walmart, so more than likely they like Walmart more than they like Target, or at least some of them would. Okay, the second one. You put all student names in a hat and pull out 25 random students to ask their favorite school lunch. If you're only talking about your school, that one works. And then you ask every person in your neighborhood, what is their favorite park? Well, their favorite park is probably a lot different than a favorite park of somebody who lives in Wisconsin, right? And so since you're picking only people who are nearby, they're probably going to pick a park that's nearby. So that one would really depend on if your whole population was your neighborhood, well, then you didn't really do a sample. You kind of surveyed everyone. But if it was like the city or somewhere even bigger, then that one's definitely biased. Okay, then we moved on to doing mean, median, mode, and range. And then we talked about something new called outliers. So when we find the mean, median, mode, and range, I always think the best thing to do is, very first thing is to line up our numbers in order from least to greatest. So I like to rewrite the number set in order because it is very helpful for different things. And when I'm done, I like to double check to make sure I got them all. I like to count them. So I go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, I have them all. So if I'm finding the mean of a data set, that means I'm finding the average. So I'm finding kind of the middle. Think about that as like if these were all pieces of candy that people got, one person got one person got two, all the way to that one person down here was lucky and got 15 pieces. It's like we said, okay, everybody dump your candy into a bowl and we're going to hand them out one by one by one. So we're trying to make it so that everyone has the same amount. And so when we do that, we could do what I call the even it out method, and we could take this 15 and we could give some extras and we can hand them out to the other people. Or we can just add up all those numbers, which is 36, and then divide by how many numbers there are. If you remember, there were 8. Okay, and that gives us 4.5 pieces of candy per person, or 4.5 is the mean or the average. The median is where we look and we say, okay, I have them all lined up in order from least to greatest. I want to find which one's the middle of that group. So which person has the middle amount of candy? See how that's like a different middle? Ooh, there's 2 people that are in the middle of that. And I want to find out what would be in between them. So what would be in between 3 and 4? Well, that would be 3.5 or 3.5. Okay, the mode is the one that we see the most. So I see 1, 1, 1, 2, 2 3s, 3 4s, and 1 15. Okay, so 4 wins. there's the most 4s. If there was another 3 in there and there was a tie, we would say 3 and 4 are both the modes. If there was only, if it said 1, 2, 3, 4, 5, 6, 7, 8, and none of them were repeated, then we would say there is no mode. The range is how spread out they are. So we're going to take our biggest number and we're going to subtract our smallest number, and that's how spread out that group is. They're 14 apart. Okay, and then the outlier. The outlier is something new. It's saying, are there any numbers that don't really fit in the data set? Is there a number that's quite a bit bigger or quite a bit smaller than the rest of the numbers? And I noticed that like these numbers here are all really close and tight together. Think about if these were ages of kids and we had a 1-year-old, a 2-year-old, a 3-year-old, a 3-year-old, a 4-year-old, a 4-year-old, a 4-year-old, and then we had a 15-year-old. That 15-year-old would not fit that group, right? Maybe they were like the babysitter, right? So the 15 would be an outlier. So with that outlier, what did it do to our middle values? Well, if we look at all of these, right? Let's go back to calling it pieces of candy. Did any of these guys get more than 4 pieces of candy? No, but the average, it's saying the average person got 4.5. Well, that doesn't seem true. It's because this person had so much candy, right? This one was so much bigger. So it increased all the measures, increased the measures of the middle. If I had a number that was much smaller, it would decrease the measures of the middle. Okay, so we learned about a whole bunch of different ways that we could look at data. A stem and leaf plot is one of the ways that we could look at it, where the stems are the tens place and the leaves are the ones place. So for example, this is saying 52, 48, 32, right? So I'm going to ask a question on these. And I'm going to ask, for this one, I'll ask a couple things. Like, what's the biggest number? Well, that's 66. Or maybe I ask, what's the smallest number? Well, that would be just 1. Okay? I might say, what is the range of the numbers? Well, take the big minus the small. They're 65 apart. Okay? So those are some questions I might ask for something like this on a stem and leaf plot. On a box and whisker plot, I'm probably going to ask about one of these 5 numbers. So here are my 5 data points, okay? This one here represents the smallest number. We call it the minimum or the lower extreme. This one here represents the maximum, the highest number, or the upper extreme. Then this one in the middle, that's my median. And these ones on the sides, we have 2 names for them. We either call it Q1 and Q3, quartile 1 and quartile 3, or we call it the lower quartile or the upper quartile. And this box in here is our inner quartile. Okay, we talked in class about how this represents 25% of the data, this represents 25% of the data, this represents 25%, and this represents 25%. So this box in the middle is like the middle 50%. So we're still kind of talking about those middle values. I might ask you, what's the smallest number? You'd say 24. I might say, what's the biggest number? 34. I might say, what's the median? That would be what goes here, which is 31. What is the range? 34, take away 24, that would be 10. What's the inner quartile range? That would be this number, 33, minus this number, 27. So that would be 6 as my inner quartile range. That's how spread out this box is. Okay, a histogram is very similar to a bar graph, except for how we make it, right? And so we see that this one's talking about the age of people, and the frequency would be how many people were that age. So as you notice also, these bars represent a range. So this bar represents the range of people from 20 to 30 years old. So I might ask you a question like, how many people were in their 90s? And you would look at this bar and you would say, well, there's 1. Okay. I might say, How many people are between 40 and 70? Well, that would be all of these 3 bars. And so if I looked at each one, this one's 4, this one's 5, this one's 3, and I put all those together, and I'd say there are 12 people between 40 and 70. So it's just asking you to look at those bars and be able to count how many people. And then scatter plots was the only other big one that we talked about for ways that we can show data. And when we look at this, we're kind of looking to see, do these dots sort of line up? When they sort of line up, it means that there's a trend in the data. There's either a downward trend or an upward trend. So if you can't tell that there is a trend, then we would say there is no trend or there is no correlation. Okay, but we notice in this first one that there is a downward trend, and we don't call it downward in math, we call it a negative trend. And later we'll talk about that as a negative slope. And then we've got this other one over here, and you can see it kind of goes up, like if I were to draw a line through the middle. And so an upward trend in math, we call that a positive trend or a positive slope or a positive correlation. Okay. Lastly, you are going to get a misleading graph. It's trying to tell you something that's not correct. You have to give a reason why it's misleading. All of these examples here on this page are things that you could pick if they apply. So these are good reasons why a graph might be misleading. For example, they have different sized icons or graphics. That's like if it's made out of pictures and the pictures are made out of different sizes, then that could be misleading. If the scale doesn't start at 0. So remember when we're going on a y-axis, it should say 0 and then count by something. So let's say it counts by 2s, 2, 4, 6, and then 8's supposed to be next, but what if I jump to 20? That would be not having equal intervals. So it needs to count by the same thing all the way up. And then if the totals don't add up, that's talking about a circle graph. Circle graphs always need to add up to be 100. If they don't, then we know that it's misleading. And then lastly, if the title includes an opinion, like everyone's favorite color is blue, well, that's an opinion. It's not a fact. Okay, so we have 4 examples of misleading graphs. Here's 2 of them. And we're going to look and we're going to try and figure out why they're misleading. So I'm going to look first. I noticed that it doesn't have a title. It doesn't have an x-axis label, and it doesn't have a y-axis label. But that is not a reason for it to be misleading, because just because it doesn't have a label doesn't mean it's trying to tell us something, right? So this is trying to tell us something that's not true. And I noticed that there's 40, 45, 50, 55, 60. Well, that counts by 5s, but notice it didn't start at 0. Okay, so that would be the reason why this one's misleading. And it looks like these are more similar than they actually are because of that, because we're missing the bottoms of these charts. So it's going to look like pizza's even higher up there. And then this next one, you might say, well, all I see is that it's missing these titles. Well, missing a title, again, isn't going to be a reason for a misleading graph. But notice how this has a lot of white space up here. And it's kind of hard to tell that this line is going down then up. Well, I don't think I would count by 5s, because you really want to be able to use the majority of the graph. So I think that they should have counted by 1s or 2s to make this a more exaggerated look on the graph. That would make more sense. Okay, then we have 2 circle graphs. This circle graph over here, it does add up, but these 2 pieces that are pulled out like this is kind of like that graphic where this is a lot bigger than the other part. And so it makes it look like it's a bigger section than it really is. And then this one, it doesn't add up to 100. And so that would be the reason why it's misleading. It's actually way, way more than 100%. All right, I hope that you do really well on your test. Have a good day. Bye.